everyone, and welcome to today's video on applying the Pythagorean Theorem. So we've already proved why the Pythagorean Theorem works, and we've had a little bit of practice using it just to find the missing lengths of triangles. Today we're going to see some examples of when it's useful in the world. As a reminder, the Pythagorean Theorem says that the sum of the squares of the legs of a right triangle, so we say our legs are A and B, those are the shorter side lengths that form the 90-degree angle. We take the square of those and we add them together, so a squared plus b squared, that's always going to be equal to the square of the hypotenuse. The hypotenuse is the longest side and the side that's across from the 90-degree angle and not attached to it, doesn't create it. Okay, so a squared plus b squared equals c squared. Let's look at a word problem example. So we have that Mark works 5 miles directly south of home, and Sam works 3 miles directly east of their home. When Mark and Sam are both at work, how far away are they from each other? Okay, so if we see a problem like this, you always want to draw a picture right away. Having a diagram is going to be super helpful, particularly with Pythagorean Theorem questions. So I'm going to draw this out. I have home. And then I have that Mark works 5 miles directly south of home. Okay, so south is this way. This is Mark. And a compass, we have north, south, east, west. So Mark is 5 miles south of home. And then Sam works 3 miles directly east of their home. Okay, east is this way, so 3 miles this way. And this is Sam at work. So when they're both at work, how far away are they from each other? Okay, so you might be inclined to say that they're 8 miles from each other, but that's not the most efficient way to get between Sam and Mark, right? Not to go through home. To find the actual distance they are between each other, you want to find the straight line. The shortest distance between 2 points is a straight line. So the straight line that connects Sam's location and Mark's location. Okay, and how can we do this? Well, we've now formed a right triangle, and we can find the missing information. So now that I have my picture, I'm going to go to the second key thing we always want to do when we're solving these Pythagorean Theorem questions. We're going to write down the Pythagorean Theorem. So we're going to write down a squared plus b squared equals c squared. And then I'm going to figure out what am I given, and then what do I need to find. So am I given 2 legs and I need to find the hypotenuse? Or am I given 1 hypotenuse and 1 leg and I need to find the leg? So what am I trying to find here, A, B, or C? Yeah, I need to find the hypotenuse. I'm given 2 legs, so we'll let this distance 3 miles be A, we'll let this distance 5 miles be B. Doesn't matter of those, which one I label A and B, but the hypotenuse has to be C. Right, and that is what we're trying to find here, that kind of diagonal distance that's across from the 90-degree angle. So now that I have that, I'm going to substitute in my information. I have A is 3, so I have 3 squared. B is 5, so I have plus 5 squared, and that equals c squared. Now, of course, I need to find the value of the left-hand side. What's 3 squared? 9. What's 5 squared? 25, so I get 9 plus 25 equals c squared. Then I have 9 plus 25, which is 34, so we get that 34 equals c squared. At this point, I have some number squared, so multiplied by itself equals 34. I'm trying to solve for c, so I need to undo squaring something or use the inverse operation of squaring. So what's the inverse operation of squaring? How do I undo squaring something? Perfect, we take the square root. So we're going to take the square root of both sides, because of course if we do something to one side of an equation, we have to do it to the other. And then we're going to get, technically we get plus or minus the square root of 34. We could get the positive or the negative root when we have it set up in this sort of equation. But whenever we're dealing with the Pythagorean Theorem, we really don't worry about that because distance can never be negative. So the exact distance is the square root of 34. And then we can go on our calculators, as I'm doing right now, and I can find the square root of 34. And when I do that, I get that c is about 5.5 5.8 miles. Okay, since this is a word problem, it's always good to have a wrap-up conclusion sentence. So how far away are they from each other? Sam and Mark are about 5.8 miles from each other when they are both at work, right? Or exactly the square root of 34 miles from each other. Great, so obviously that is less than the 8 miles, right? Because if we take that diagonal, that's going to be the shortest path. Awesome. All right, let's try another. A 12-foot ladder is leaning up against the side of a building. The ladder is 5 feet from the building. Jennifer is using the ladder to try to reach a flag 10 feet straight up from the ground on the side of the building. Will Jennifer be able to reach the flag? So I know what you might be thinking. There's a lot of words here. This is very stressful. I don't like word problems. We can totally handle these problems. If you're not thinking that, amazing. We just need a picture. A picture is going to be super helpful here. Okay? So I'm going to draw my building to start off. I have some building. And then I'm told that a ladder is leaning up against the building. Okay, so let me draw that. Here's a ladder leaning up against the building. Okay, and the ladder is 12 feet long. So this distance is 12 feet. Okay, and then we are told that the ladder is 5 feet from the building. So the base of this ladder is 5 feet from the building. This is a distance of 5 feet. And I'm trying to figure out, Jennifer is using the ladder to try to reach a flag that's 10 feet straight up from the ground on the side of the building. Will Jennifer be able to reach the flag? So we're not quite sure how far this distance is, but we need to figure that out because somewhere along here is the flag. I don't really want to draw it yet because I'm not sure exactly where it is, but somewhere along there is a flag and we're trying to figure out, will Jennifer be able to reach it with this ladder? Okay, so in order to do that, we need to find where the ladder hits the building, right? How high is it getting us up the building? So in order to do that, we're going to use the Pythagorean Theorem. We should zoom in here a little bit. We should see that we have created a right triangle. Okay, and in the right triangle, the hypotenuse is 12. This is my C, my hypotenuse. Then I have one of the side lengths. I'll call that B. And we're going to try to find A, the other side length. So let's begin by writing down the Pythagorean Theorem. We have A squared plus B squared equals C squared. And then I'm going to substitute in my given information. So I don't know what A is. That is one of my legs. But I do know B, the other leg, is 5 feet. So that's going to be substituted in for B. And then I know C, the hypotenuse, is 12. Okay, so I get A squared plus 5 squared equals 12 squared. Okay, now let me go ahead and solve this. So I have A squared plus 5 squared. 5 times 5, or 5 squared, is 25. And then that equals 12 squared, which is 144. Now I'm trying to find A. A needs to be all by itself. Right now there's two things bothering A. A is being squared, we don't like that. And then 25 is being added to A squared. So first we want to get rid of this plus 25. So solving an equation, how do I get rid of a plus 25, or how do I undo adding 25? Exactly, I'm going to subtract 25. So I will do that on both sides of my equation, just like if I were solving any of our normal equations where we don't have squares. 25 minus 25 is 0, so I get that A squared equals 119. That's 144 minus 25. Now again, I have A squared equals 119. I want to get A though. So how do I undo that squaring? What's the inverse operation of squaring? Perfect. I take the square root. So I'm going to take the square root of both sides. And that will give me A equals exactly the square root of 119 feet. Or if I want to round, I can go to my calculator and do what is the square root of 119. And I'm going to get about 10.9 feet. Okay, so I feel like we're done, but then I'm like, wait. What was the question asking me? The question said, will Jennifer be able to reach the flag? Okay, so the ladder is getting me here. This is 10.9 feet up from the ground. And then the flag is right here at 10 feet. So will Jennifer be able to reach it? Yeah, she might need to move her arm down a little bit, but she's high enough to reach it, to grab it. So yes, she's going to be able to reach it. So finally, since it's a word problem, we want a conclusion sentence. Yes, Jennifer will be able to reach the flag because the ladder will get her 10.9 feet up the building. And the flag is only 10 feet, so she'll be able to grab it. There's my conclusion sentence, and we're good. So to summarize in this problem, we had to draw a picture, solve using the Pythagorean theorem, and then go back to check what the question was asking us and address that question. All right, let's see a final example. So the last thing we can do with the Pythagorean theorem is we can use it to find distance, which is kind of like what we did in the past two questions. In like a word problem situation, we're finding the distance between the ladder and the ground, or the distance between Sam and Mark. Yeah, Sam and Mark. But we can also just find the distance on a coordinate plane, which has its uses as well. So example 3, we're trying to find the perimeter of triangle XYZ, whose vertices are 2, 5, 5, -1, and 2, -1. So those 3 points are graphed here. Okay, so we need to find the perimeter. So let's review. What does the perimeter mean? Is the perimeter the distance around the shape, or is it the amount of space that's inside the shape? Yeah, the perimeter is the distance around a shape, so it's like the sum of the side lengths. So in order to find the perimeter of a shape, we need all of the side lengths. Okay, so first let's find the side lengths that we can just see immediately on my triangle. So the side length from Z to Y, I'm going from an x value of 2 to an x value of 5. To find distance, I can subtract 5 minus 2, which is 3. Or I could count the units, 1, 2, 3. Okay, so that is going to be 3 units. Then I'm going to do the same thing for x to z. This down here, this is -1. This is 5. So -1 minus, so 5 minus -1 is 6. Or I can count, that is 1, 2, 3, 4, 5, 6 units. Okay, so pretty good shape with the perimeter, but now I need this distance, which I don't have, right? But of course, I can figure it out. How? Using the Pythagorean theorem. So I'm going to actually have you do that. Tell me what the hypotenuse is in this triangle. Remember, we always begin by writing the Pythagorean theorem down, and then we substitute in our given side lengths and solve for the missing one. So find C, the hypotenuse of this triangle, or side length xy. So you should have found that the side length xy, or the hypotenuse, has a length of the square root of 45 units, which is about 6.7 units. So now we need to find the perimeter of this triangle. So to do that, we're just going to add these lengths together. Okay, so we have 6 units plus 3 units plus the square root of 45 units. 6 plus 3 is 9, so we get 9 plus the square root of 45 units. Okay, that is the exact perimeter of this figure, but often it's useful to get a rounded answer, so we can do that as well. Or we do 9 plus 6.7, which is about 15.7 units. So for these perimeter problems, we need to find the lengths of all 3 sides, which is normally going to require using the Pythagorean theorem, and then we add those together. And that's how we apply the Pythagorean theorem to solve problems. Great job, everyone!